Hello my dear students, this is Dr. Mohga and today we'll be explaining density. Our content will include defining density as mass per unit volume, knowing the equation, and how to calculate the density or the mass or the volume using this equation. We need to know how to determine the density of a liquid, of a regularly shaped solid, and of an irregularly shaped solid which sinks in a liquid. We also need to know whether an object will float or sink based on its density. Let's start. Density is mass per unit volume. You have to know the symbols very well, which represent each of the three. As you can see here, this is their equation. The unit for density depends on the unit of mass and the unit of volume. If my mass is in grams and my volume is in centimeter cube, then my density will be in grams per centimeter cube. If my mass is in kilograms and my volume is in meter cube, then my density will be in kilograms per meter cube. By now you should already know how to get the unit of the main subject of your equation. If the mass was in bananas and the volume was in apples, then density will be in bananas per apples. It is what it is. So please be very careful with the unit of everything you're including before you get the final unit. Objects made from low density materials have low mass. Objects made from high density materials have high mass. In this part, I want you to consider, for example, a feather, actually a big bag of feathers. Will it have a low mass or a high mass? They're all feathers, they're very, very light. They will have a low mass. However, on the other hand, I can have a rock. It's much smaller than the big bag of feathers, but it's heavy. It has a high density, so it will have a high mass. Now, for measuring volume, we said that we're gonna try to measure the volume of three kinds of things: regular shaped solid, irregular shaped solid, and liquid. For regularly shaped solid, you're expected to know the equations of the sphere, cube, and the cylinder. So please take your time to write them down, practice them in as many questions as possible so you can get the hang of them. So, to measure the volume of a regularly shaped solid, all I need is a ruler. Then I will apply the equations. For a sphere, its equation is 4 over 3 pi r cubed. For a cube, we multiply the diameter of the cube cubed, so d cubed. For a cylinder, we're going to do pi r squared times L. And remember, the r is the radius of the circular part on the top of the cylinder, and the length is the entire height or length of the cylinder. For an irregularly shaped solid, the only tool or instrument that I'll need is a measuring cylinder. We have 3 steps, and usually the question here is for 3 marks. So number 1, I will add water and measure the water level. You can write and label the water level, record the water level, but you have to write that you're going to record that water level in the beginning. Then number 2, you're going to add your irregularly shaped solid to the cylinder and measure the new water level or record the new water level. Third step, I'll subtract my final volume minus the initial volume. So the volume of the water and the object minus the volume of the water only. Last thing we need to know is to measure the volume of a liquid. And this one could be very easy, but it has a little bit of a trick. When reading the volume of a liquid in a measuring cylinder, you have to make sure to read at eye level to avoid parallax error. What's parallax error? It's the error that results due to reading from a wrong angle. So if you're reading while looking from a higher level, you might get the number that is below the correct answer. If you're reading while your head is below the measuring cylinder, you will read the number that's a little bit above the correct answer. Because as you know, light goes in a straight line. So therefore, be sure to always read at eye level. Here's an example. Please pause the video, try it on your own, and then unpause to check your answer. A paving slab has a mass of 73 kilograms and dimensions 0.04 meter times 0.5 meter times 0.85 meters. Calculate the density in kilograms per meter cube of the material from which the paving slab is made. Here, we have to be very careful to look at the unit of density. It's kilograms per meter cube. So before I even answer, I have to make sure that my mass is in kilograms and that the dimensions which I'll get the volume from are all in meter to give me the meter cube. My mass is in kilograms, so that's good. My dimensions are all in meters, so that's good as well. Now I can start calculating. Like we studied, density is mass over volume. So my mass is 73 kilograms over my volume, which is 0.04 times 0.5 times 0.85, giving me my final answer. 73 over 0.017, resulting in 4294 kilograms per meter cube. As we agreed, we'd like to put it in two significant figures, so my final answer is going to be 4,300 kilograms per meter cube. Here's another example. Please pause the video, try it on your own, and then unpause to check your answer. In this picture, they gave me the dimensions of a metal block, and they gave me the density. They're asking to calculate the mass of the metal block. Our original equation was density equal mass over volume. We need to rearrange the equation to find mass. So mass will be equal to density times volume. My density is 8 grams per centimeter cube, and since my dimensions are all in centimeter cube, then I'm good to go. So we're going to have mass equal density times volume equal 8 times, the volume is 2 times 2 times 3, giving me 12. So 8 times 12 is 96, and my unit is in grams. Next part of our lesson is float or sink. Usually the density of water is 1 gram per centimeter cube. So naturally, anything that is heavier than 1 gram per centimeter cube, if I place it in water, it's going to sink. If it has a density that is less than 1 gram per centimeter cube, then it will float. So whether an object floats or sinks depends on the relative density of the object and the fluid it's submerged in. So we can't always compare it to 1 gram per centimeter cube, like we just said. This is if I'm placing it in water, then I compare it to the density of water. If I'm placing it in a different kind of fluid, then I have to compare it to that density of that fluid. If the object is denser than the fluid, it will sink. If the object is less dense than the fluid, it will float. Here's an example. Please pause the video, try it on your own, and then unpause to check your answer. Two objects P and Q are placed in a beaker containing a liquid. Object P floats in the liquid and object Q sinks. Which row for the densities of object P, object Q, and the liquid is possible? Remember, they said object P floats, which means that I need to make sure that the density of object P is less than the density of the liquid. So A is not correct, since it's more than the density of the liquid. B is not correct, 1.2 is more than the density of the liquid, which is 1. C, 11.3 is less than 13.6, and D, 11.3, is less than 13.6. So we have two possibilities here. Let's check the rest of the question. Object Q sinks, which means that the density of object Q should be more than the density of the liquid. So going back to C and D. In C, the density of object Q is 8.9, which is less than the density of the liquid, so it's incorrect. In D, the density of object Q is 19.3, which is more than the density of the liquid, which is correct. So since the density of the liquid is 13.6, P's density is 11.3, which is lighter, it will float, and Q's density is 19.3, which is more dense, so it will sink. Hence, the answer is D, because P should have less density than the liquid to float, and Q should have more density than the liquid to sink. Here's another example. Please try it on your own. Pause the video, and when you're done, you may unpause to check your answer. A cookery student pours some cooking oil into a glass bowl containing water as shown in figure 3.1. The density of the cooking oil is 0.92 grams per centimeter cube. The student accidentally drops a plastic spoon and a metal spoon into the bowl. The densities of the spoons and liquids are shown in table 3.1. On figure 3.1, label a suggested position for each spoon after each has fallen into the bowl. Use the letter P to label the position of the plastic spoon and the letter M to label the position of the metal spoon. Now, we can see that the water is at a density of 1.0 and the cooking oil right above it is at a density of 0.92. Let's compare where the two spoons will be allocated compared to the cooking oil and the water. The metal spoon has a density of 8.7, which is heavier than both oil and water. So it's going to sink even below the level of water. The plastic spoon has a density of 0.76, which is lighter than both. So it will be floating on top of the cooking oil. So P on top of the liquid surface and M on the bottom of the bowl. That's all for today. Wishing you all the best. See you in the next video in the next lesson. Have a good day.